This video is about multiple comparison testing using R. It's not a very pleasant experience to do multiple comparison testing using R because base R does not support much of multiple comparison. We need some other packages and the things are haphazard to say the least. So we shall be using a couple of packages. In fact, we shall be using one package specifically, which is a rather weird name, agricolae. I am going to give you the spelling. But before that, let's clearly understand what type of data that we are going to work with. We shall see how to perform Fisher's LSD and Bonferroni type tests. So the setup that we'll be working with will be like this, that we have some plots and plots of sweet potato, and there are a couple of viruses that are being fed into it. In fact, there are two viruses. And out of these two viruses, we have got four possible combinations. So virus 1 is absent, virus 2 is absent, virus 1 present, 2 absent, 2 present, 1 absent, and both of them are present. As a result, we have got four classes. So virus has got four levels. It's a factor input. And you are getting plots and you are measuring the yield of sweet potatoes. So it's a one-way ANOVA setup. Now, we are interested in knowing whether virus has any significant role to play. And if so, we want to compare between these four different levels. That's the problem. So let us see how to do this using R. We are first loading this package, library agricolae. It has to do something with agricultural statistics or whatever. And the data that you are working is with sweet potato, which is part of that package. So I'll be using that. And you have to load the data here. If you do not load the data, then somehow it doesn't work. And let's see. Let's take a quick look at this. So let's run it. And I will run data sweet potato. So here we have summary. Virus, there are these four possible strains. So OO means no virus, and FF means the same virus. That F virus and C virus both present, and only C virus present, and there are everything is repeated thrice, and yields, we have all these things. And if you want, we can also just look up the help of this using question sweet potato. I'm not going to go into that. You can, if you want, you can try to take a look at the help. So it says exactly how the data were collected, etc. Anyway, so the first thing that we will do is Fisher's LSD. Remember, Fisher's LSD has got two steps. The first step will carry out the usual ANOVA test. So let's do that. So I am fitting yield on virus, and then I am fitting the null model, and I will do an ANOVA, and I get my little ANOVA table where I find that this p-value is quite small, highly significant, significant at level even 0, at level 0. So it's very, very significant. So this means we pass the first test of Fisher's LSD. We do not say accept in all the cases. We do say, we know possibly there is going to be at least one reject. Some two levels differ in terms of yield. Okay, so we carry out LSD test. So LSD test is something which is in this package. So I write out LSD test. Let's carry out the test. And I want to see what's inside out. And I get lots of things. Of that, I care about this part, this comparison thing. So you have all the possible combinations. Remember, there are these four things, CC, FC, FF, and OO. So CC is being compared with the remaining three. FC is being compared with the two. FC is not compared with CC anymore because that is already done. So these are n choose too many comparisons. Here n is 4 different levels. and so there are 6 comparisons, and for each one of them the difference has been computed and the p-value. So you remember how you do that. It is just like the 2-sample t-test, except that the denominator, the pooled variance, the pooled standard error, the standard deviation, that is sigma's hat, that is obtained from the RSS divided by degrees of freedom of error. And you are just doing the test, the law t-test, and you are getting all this stuff. Now from this you can say that, well, this we have accepted 0.88, which means FF and 00, that's not much difference, but and if you are working at 5% level, everything else is significant. So that is one way of drawing the conclusion, but eventually your aim is to say that this thing is like that, that thing is like this, so you want to group them. Now you can do that grouping here by looking at it and then taking a piece of paper and making a record. FF is basically same as 00. 00 is not same as FC, and like that, but this program can do that stuff for you. So let's quickly see how it can do that. So here you notice I wrote group equal to false, and that is the default. Now if you write group equal to true, in that case it will do the grouping for you, but it will not provide you with this comparison table. So it will keep this internal to itself. So if I do that, let's just see, and you see I also put some additional parentheses, which means it will not only compute it but also print it. So here I have to save it in a variable and then write the variable separately on a line. So get the value inside the variable. Here I can do both the things in one go. So let's just quickly do it. So if I do that, I will get this. So in this case, that comparison field is now null. So the comparison table is not given. Instead, you are getting a groups thing. So you have got the 4 things, OO, FF, CC, FC, and it has given group levels. It creates them automatically, ABCD, etc. So AA means OO and FF are both in the same group, which is at arbitrary level as A, but CC and FC are actually in different groups. So there are basically all these 4 different levels may be grouped into 3 groups. The first group consists of OO and FF, second group consists of CC, and the third group consists of FC. Now, there's a little problem here because exact equality is transitive, but approximate equality is not. So it may happen that you say level 1 is same as level 2 approximately, level 2 is same as level 3 approximately. That does not mean level 1 is same as level 3 approximately. So a friend of friend need not be a friend. So that might happen, and let's see how we tackle it. And for that we will take the next test, namely Bonferroni test.